Okay, welcome to a lesson on special case trinomials. What makes these trinomials special is we're usually going to be dealing with something called a perfect square. So it would help if we started by just writing special cases so we know what we're working with. Okay, and then maybe we just talk about what's a perfect square to start, okay? So 1, 4, 9, 16, 25, 36, 49, and that's probably enough. Okay, we can keep going, right? All the way up to 100, and we could keep going from there. But what makes these perfect squares, right, is we know the square root of all these numbers. These numbers are all made up by two numbers that are identical to multiply by each other, right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on and so forth, right? 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10. Okay, the tricky one, believe it or not, that kids forget is 1. Okay, so if we know these are perfect squares, okay, then we're going to be looking out for them in our problems. So that'll kind of help guide us a little bit. So let's take a look at what a perfect square trinomial is. Okay, so if you remember, let me move this down here some. Let's see if I can move this. Okay. If you remember from several weeks ago, there was a case where we would have x, say, plus 9 times x minus 9. And we called these special cases when we were multiplying these. So this was before the global pandemic. We had a test on this, and we took the x and we multiplied it by x, and we got x squared. Then we took the x and we multiplied it by 9, and we got negative 9x. And then we multiplied that by 9 by x, and we got positive 9x. And we took the 9 and we multiplied it by negative 9, and we got negative 81. And in this case, these two middle terms went away, right? They became 0. And we were just left with x squared minus 81. And that was our answer. Those were called one of the special cases we worked on. So now I'm going to give you things that look like this, and you have to factor them to look like that. Okay, so in order to factor them, we've done the x and we've done the factor by grouping. But when you see, okay, something squared, okay, minus something else, which you know is a perfect square, this right here has to be a perfect square. All right, and if you're confused what those are, scroll up or just pause and go back and look at the perfect squares I listed. Okay, if that's a perfect square and this could be made up of two identical things multiplied by each other, okay, they have to be the same, then we can just write the answer as x plus whatever the square root of this is times x minus whatever the square root of this is, which you can see up here is 9 and negative 9. So now we look at this example over here, okay? It looks a little different, okay? So we know it's different from the start, and we know the answer is going to be two binomials, okay? We know a z is going to go here, and we know a z is going to go here. So what number is going to go here and here? Well, we know the middle term is missing, so that means this has to be positive, and that has to be negative. And then we know that's a perfect square. The square root of it is 2. And you're done. Z plus 2, z minus 2. Okay? So let's take a look at another one. Maybe this one's a little bit harder. Let's do 4x squared minus 25. Okay, we'll call this example 2. Okay, now in example 2, we have to ask ourselves here, is this a perfect square, and is this a perfect square? Well, we know this is a perfect square, right? The square root of it is 5. And what times what, which is the same thing, would equal 4x squared? 2x and 2x. Basically, can you take the square root of this? right? And I can take the square root of 25, it's 5, and I can take the square root of 4x squared, it's 2x. So that's where I get the 2x times 2x from, which we only need 1, right? Because we just want the square root of it. So those are my two pieces that I'm looking for. So my answer is just 2x plus 5 and 2x minus 5. Nice and easy. Okay? You have to have the plus and the minus. Very important. Otherwise, the middle term doesn't go away and you don't end up with the two terms you started with. Okay? So stop that here and maybe go back and do a couple problems and see if you get the hang of that. And then play the video for special case number 2.